Why power grids still need synchronous condensers. Welcome to this presentation on why power grids still need synchronous condensers. As we move into a renewable energy era, maintaining stability and reliability in power systems has become more challenging. Synchronous condensers continue to play a critical role in meeting these challenges. The enduring need. Synchronous condensers, or SCs, remain vital for modern grids. They provide voltage regulation, reactive power support, inertia, and grid strength. As traditional power plants retire and renewable energy grows, these services are more important than ever. Voltage regulation. Voltage regulation is one of the most important functions of SCs. By supplying or absorbing reactive power, they maintain stable voltage levels, prevent voltage dips, and ensure reliable operation of electrical equipment, even in regions with high solar and wind penetration. Inertia provision. Traditional power plants offered significant inertia through their large rotating masses. As we shift toward renewables, that natural inertia is lost. Synchronous condensers provide this missing inertia, helping to stabilize grid frequency and reduce the risk of blackouts. Short-circuit current contribution. During faults, protective devices like circuit breakers rely on strong fault currents to operate correctly. SCs contribute short-circuit current, ensuring that faults are detected and isolated quickly, which prevents damage and widespread system failures. Grid strength. By combining dynamic support with fault current contribution, SCs enhance overall grid strength. This makes the network more resilient to disturbances, fluctuations in renewable supply, and unexpected equipment failures or weather events. Cost effectiveness. Compared to alternatives such as batteries or static VAR compensators, synchronous condensers are often more cost-effective. They offer lower upfront costs, longer service life, and proven performance, making them an attractive solution for grid operators. Support for renewable integration. Synchronous condensers are particularly valuable in renewable-rich systems. They smooth out fluctuations in solar and wind generation, provide reactive support, and supply inertia. This enables operators to integrate more renewable energy without sacrificing reliability. Proven technology. Unlike newer technologies, synchronous condensers are a well-established and trusted solution. With decades of successful use worldwide, they represent a dependable, low-risk choice for grid stabilization. Stabilizing U.S. power grids. In the United States, synchronous condensers are increasingly being deployed in areas with high renewable penetration. These projects demonstrate their effectiveness in ensuring grid reliability, even as conventional plants are phased out. Conclusion. In conclusion, synchronous condensers remain indispensable for modern grids. Their ability to provide voltage regulation, inertia, short-circuit current, and overall resilience ensures that power systems remain stable during the energy transition. As renewable energy continues to grow, the role of synchronous condensers will only become more critical.